So thank you for the invitation to give some presentations there. Just before to explain from where I am talking, so where we are at the CEA, probably some of you have heard about CEA-Leti and perhaps CEA-List, but CEA is a very large research institute. It's a research and technology organizations, but with also fundamental research on fundamental science, with 20,000 of employees and so on. I don't give the details. Concerning the digital aspects of activity at the CEA, it's a quite huge subject for CEA, with both compounding and components, mainly until microelectronics, artificial intelligence, system integrations, and system and communications. And artificial intelligence is identified at the global level of the CEA as a particular strategic track, and it's one of my functions to represent this track. So our activities in artificial intelligence can be viewed from 2 points of view. One is on using AI for science and application for the society, and it's a very important track, and also making and working on the artificial intelligence technologies and research themselves. And we are on both aspects. Just to illustrate the innovative ecosystems, we have several centers in France. All of them are some considerations related to artificial intelligence, but the two main poles of activities related to artificial intelligence are in Paris-Saclay area, CEA-List mainly, but also some other directions working on fundamental science for energy, climate, astrophysics, health, and so on. And the focus on the research on AI itself is mainly on trust and frugality, with some considerations related to embedded systems. And the second strong pole is in Grenoble, in associations with CEA-Leti and CEA-List, because CEA-List is on both sides and focus on hardware for edge artificial intelligence. There is some infrastructure supporting the research. On one side, a dedicated computer for AI simulation computations, and it's quite important because it has been built really with to answer to the need of machine and intensive machine learning, and also to be able to work with some confidentiality constraints with the industrial partners. So it's quite different from the large and very more powerful computer called Janzé that is more dedicated to open research, that creates some additional constraints or limits. And obviously regarding hardware, we have the cleaning rooms in Grenoble. So the idea comes from several years, mainly not so early, but in 2017, when we observed that AI was coming with a large impact, with predictions that it could cover 10% of the economic activity of Europe. It's very important for a single technology track, so it means that it will impact a lot of domains, and with a large amount of possibilities. And there is a second point that is pushed also and considered either at national and European level, that we have to consider to go from full cloud to the edge, and possibly full at the edge. So it means while inference and learning are made in the cloud at this time, going and finding the path to have inference and learning at the edge, with a lot of advantage and expectation regarding this, at least lower latency, scalable, reliable operations, because if we are not more dependent on communications and connectivity, it means that the systems will be more autonomous and reliable, more data privacy, because if you keep the data where they are produced, you reduce the risk to display them to publicly or to attackers. And also energy efficiency, because at least you reduce the data exchange volumes, but also it will require some progress on the hardware, as we have seen this morning and probably during the 2 previous days. So it makes that regarding AI, there are more and more expectations on trust and frugality. And these 2 challenges are quite important for us and have been tackled at the CEA level by launching 2 strategic programs, one on trust and one other on embedded AI. I will not talk about this on embedded AI because here's the talk. We have decided to focus the talk more on trust, but there is a lot of activities too. So what's happened at the European level? So it's identified as a strategic issue. Also at the French, at the level of France, the state create important and funded program to support the deployment of AI. And we have also seen an association of the main large industrial and French industrial to say, okay, it's quite important that AI becomes something that will serve the industry and respect the value of Europe. And it was something important that 30 industrials together said and pushed this message, because it has helped the next actions. Now, at this time, we are in the second phase of the national plan of AI, called that has been launched in last November, with 3 focused priorities. One on embedded and frugal AI, one on trustworthy AI, and one other on foundations of AI. And it's quite important because this second phase of the strategy decide to focus the effort, not on the applications, not on all the subjects related to AI, but really on embedded and frugal AI and trustworthy AI. And it has also launched both innovation actions, it means support of industrial innovations, in collaboration or not with academics, and pure research actions for long-term research dedicated to academics on these subjects. And it will cover both microelectronics components and algorithms research. So trust. Trust, so all of you is probably convinced that artificial intelligence is quite efficient and impressive on particular tasks, in particular with perceptions or reasoning, but there is some open questions. The main point is we don't succeed at this time to easily insert inside artificial intelligence applications the notion of common sense. So that makes that if we don't learn something to the systems generally will not recognize anything. And for it, nothing is in the image, even if for a human, the conclusion is obvious. It's also something that is fragile. So we have some problem of stability of machine learning and attackable. Both are connected, but it's not exactly the same. It means that we can also learn how to make the system fail. And this is quite an open question, and with very intensive work on it. And the last one, which is perhaps the most important for the user, is it's easily misused. And one example is the first report of the first Tesla accident, where the lawyers try to find the responsibility. Is it Tesla? Is it the driver? And so on. And the conclusions was quite clear. The system was built for an usage that was not adapted to the context of a driver in a car doing nothing during several hours and having to react very, very efficiently for if some events happens. So this context of misuse of the AI is quite important and requires a lot of attention also. So, oops. From this, we are not the only who then say that. We need trust because the applications are there, but the technology arrives with a poor maturity and with evident weakness in the definition of their usage, specifications, design methods, robustness, metrics, quality, and process. I will not give solution for all of this, just see some actions trying to participate, to ameliorate, to improve the situations. Because if we don't deal with these situations, it's clear, it could be clearly a showstopper for artificial intelligence deployments. Going to a third winter, that will be a good or bad situation depending on the point of view of each. So what's happened in Europe on these subjects? So we have created a high-level expert group, mainly with academic experts in AI, but also in ethics, laws, and usage. And they work on what could be the guidelines, the ethical guidelines for trustworthy AI. And it's quite important to see that they start by ethical aspects. So before to thinking to regulations or what is trustworthy, and they push some ideas, some considerations. First, trustworthy AI should be lawful, so respect all applicable law and regulations. Ethical, respecting ethical principle and value. Robust, from a technical point of view and from the taking into account the context of its use. And they provide several requirements. This was the first work that has been declined in several application domains like manufacturing, health, justice, e-government. And from this, the European Commission built the white paper defining its visions on a European approach to excellence and trust for artificial intelligence. The key point is Europe said, okay, it must remain a human-centric AI. It means that the AI system builder is responsible of what he builds. The AI itself is not a juridical entity that could be responsible of some things. And if you remember the debate several years ago, some lobbyists push to say, okay, it is the AI that will be responsible of the consequence if it fails. And it would have been a catastrophe, I think, for the respect of the human citizen. And human rights must be respected and not subject to automated decision only. This is also a strong point. So now you are at the stage of regulations submitted to the Parliament. It is under discussions. There is thousands of amendments, so the discussion could take some time, but it should be voted in the next months. So what we have in these regulations? So it calls about the subjects, a list of prohibited AI, some rules for high-risk AI systems, obligation of transparency, supports to innovations, and so on. Just before to look in it outside Europe, there is also some actions and initiatives, but all of them are still at the stage of recommendations. It means it's not an obligation. And when you see the recommendations provided by the NIST in US, which is now the reference for the US, it's clearly said It's intended for voluntary use in addressing and so on. So the people who don't want has not to respect these recommendations. At the OECD, they push the same kind of recommendations. So at the European, it will be a legislation. It means applicable for all the countries in Europe without any modifications by the country. It's a European legislation. It's centered on usage and risk analysis. It's also quite important. It means that you have to consider first for what will be the usage of AI, and second, what will be the risk of this usage. With some forbidden usage, there are 4 systems that deploy harmful, manipulative, subliminal techniques, so you don't are allowed to manipulate the people if this can be harmful. So it's juridical definitions. You can always debate on this, but what is important is that you can debate on this. So if you consider that this use don't respect these obligations, you can go to a tribunal and ask explanations. And this is the most important. The right you have to contest some usage. Same thing for if you use AI against vulnerable groups, or if AI is used by public authorities for social scoring purpose. So we are not in China. We will not score the people directly. It's not allowed by for public authorities. In private circle, it's another stuff. It's your problem. And the last point is related to biometric identification. So applications related to biometric identifications. If they are running in real time, in publicly accessible space, and used for law enforcement purpose, so for police, for the police, it's not allowed. You can use AI for this, except in some limited cases, like terrorism threat, some particularly important crime requiring a European with a European mandate, and so on. After this, for the rest of applications, there is 3 levels of risk. It's quite simple, not too complex. High-risk systems, a lot of applications will go in this category. And in this category, if the usage domain has already regulations, these regulations has to be respected by artificial intelligence applications. That is quite hard for artificial intelligence applications. And there is 8 specific applications areas where AI can be used, but with particular regulations, additional regulations to better master the impact of AI, like biometry, educations, employment management, essential private and public services, law enforcement, migrations, and administration of justice or democratic process. So we see that they have put a lot of effort to protect, in fact, the democratical and the liberty of the citizen. For limited risk applications, so the obligation is on transparency. So they don't have to be assessed and qualified or certified regarding a particular regulations, but they have to ensure the transparency on the way they are built, and in order we can ask and verify that they are really adapted to the use case for which they have been built. And low or minimal risk, there is no obligation. In addition of this, don't forget that there is a question of data. If you are doing machine learning, you manipulate data. And data are constrained by the respect of the RGPD. And there is some discussions So if there is a lot of debate, I will don't tell a lot on this because it's quite open at this time, even if the trend seems good. But they try to think a way to allow the use of data for research activities without too much constraints on privacy, because if we don't, for example, for health, if we are not allowed to use the data for research, we cannot build the new process and so on. And the question is, but after, when we have the results of the research, when we want to exploit it, how we do with its dependencies with data that comes from private persons. So the debate is there. Okay, so now come back to the trust aspect for AI in the context of this regulation that will require to assess that the systems will fulfill with their regulations, in particular, to ensure its trust. And trust could be considered with two kinds of point of view. And it's quite important to make these distinctions because the questions are not processed in the same way depending on the point of view. There is a point of view related to software engineering with certification, quality, safety, security, privacy, reliability. All of this is relevant for software system and software engineering. And there is other aspects related to ethics, social impact, fairness, transparency, explainability, interpretability is perhaps somewhere behind, but it's more related to the usage. And its importance is really dependent of the usage. Sometimes we don't need explainability. In the car for automotive vehicle, you don't want he explain to you why he stopped at the red light or not. You just want that it works very well. Okay, for this challenge, we have tackled this at CA with several actions. Here there is a list of some of them. I will not present all just go through some particular actions. And all of them, and more other, are required to ensure really the capabilities to develop trustworthy AI and to respect the regulation that will be adopted in the next months. So first, it's a focus on a national program, Confiance.ai. It's one of the it is the largest program on AI for the first phase of the national strategy, dedicated to trust, with collaborations between academics and large industrials. At CA level, it's a very structured program because it involves more than 35 people, and in addition, some tools developed at the CA before the programs. It has been organized with 3 stages, with considering 4 stages of the development. One is on the data management. One is on the design, one is on the validations of the applications and the system, and the last one is on the deployment. And with a common track considering how to build a process and methodology that can ensure the consistency on all the stages. And this is somewhere the key for developing trustworthy AI is to have answers on all these 4 stages. We have several use cases. Here I have put 3 use cases coming from Renault. It's a real use case with real data and a real system that is ongoing to be online. One is for manufacturing, the control of weld sim, and the question is to qualify the neural network applications in terms of development process, robustness of the results, and trying to evaluate how this system is robust. So can we replace a human control by these systems, and how to warn the existing experts that sometimes the system is not sure about the results, or we don't have to be confident about the results in particular context. The second applications is an expert systems, classical AI, that is dedicated to the management of intersection crossings. So it's quite interesting to see that a car builder comes with expert system applications. It was quite a surprise, an expectations. Do they use this kind of applications? Yes. And so there's a question is how to ensure the safety validation of this application. That is quite critical, because if you fail in the decision to cross the intersections, it could deal with very severe impact. And the questions are, is the set of rules complete? How can we guarantee that the completeness, and formally the completeness of the rules? And is it consistent? How do we guarantee that we will never have some conflict in some rules? And this question is not so obvious and also open for research, because the set of rules is quite huge and complex. And the last application that just starts is on opinion mining. So they analyze the exchange with their customers, and the idea is to qualify the robustness of the system, its accuracy, and the capability to explain the results of this opinion mining for natural language processing. So it gives a good coverage of all the questions we have to deal to answer to the expectation of industrial willing to integrate artificial intelligence in their systems. So just focused on formal methods for AI, you understand that it is a little in my background, so it's obvious that I am interested in, but it's not obvious for AI researcher that formal methods has something to do with, in particular, machine learnings. And so the idea is to demonstrate that we can provide some elements and valuable elements to validate the systems. Obviously, we apply this also with some other domain, constraint solver, expert system, as I said, or a more classical clustering approach where formal methods are much more easier to use and apply to have the answer. So, two examples. One is how to introduce formal specifications of neural networks for formal validations. Knowing that formally defining what is an image or what is in the image or what you want to recognize in the image is something that we don't know. We cannot do it, because if we would be able to formalize it, probably we don't need neural networks to make the perceptions. So it's quite inherent of this kind of applications. It's obvious on image, but it's the same from some other signals. And then the idea is to say, okay, we will start by changing a little the definition of the problems and separating the functions in two steps, one related only on the perceptions and one related only on the decisions. And trying to validate the part of the neural network related to the decision aspects, assuming that the perceptions respect several hypotheses. And for this, we will use, instead of the image, a simulator of image. And this simulator, by construct, know what he puts in the image. Even if it's a little complex and not obvious to get the information, by construct, the simulator that generates images know what it generates, why at this moment, and so on. So it helps to specify from the generators what is expected in the inputs, and then what are the specifications of the final decision steps. So you have one publication that refer this if you want more details. So it's just a first way to say, okay, we can find some approach to exploit the formal methods. And the interest there is that we can totally prove the correctness or not of the decision part of the systems. Second example is from an application use case, an industrial use case built for Technips. It's on C platform performing oil extractions, and the idea is to detect if the mooring lines breaks or not. And it's quite important because there is a lot of mooring lines. The weather is not very nice, and if too much mooring lines are broken, the platforms can move too much and break the oil extraction pipelines, and it's a lot of pollutions. It has a lot of cost in terms of insurance, and really the challenge was to be able to detect this very easy and efficiently. So Technips teams, from their knowledge, builds a neural networks that from the movement of the ship, only from the movement of the ship, was able to detect which line could be broken, and in fact is broken. And it's quite interesting because only by observing digital information signals, you can detect a problem on a mooring line without having to drive to check all of them several times. And for this, they need to convince the insurance society that their system runs. And so we work together with them on two stages. One, formal verification on some safety properties to define the safe operating domain for these applications. And through the formal method, we was able to have an exhaustive computation and validations of the input domain for which the systems detect failures. And outside these domains, there is a risk it didn't detect. One example of the results was the systems runs very well if the waves are below 5 meters. We can say, okay, it's not satisfying. We want it work every time, but not. We said, okay, if the waves are below 5 meters, it runs. So during the bad weather that is generally that has generally short durations, we don't look at the systems. But after, when the wave becomes under 5 meters, we'll be sure to detect all the mooring lines that could have been broken during the bad weather. So it's, in fact, a very strong result. And the second one is on robustness evaluation, so to work on the sensitivity to introducing disturbances on the inputs, but not working by just testing value with some perturbations, but evaluating if some profile of perturbations could be acceptable or not. So for all the domain of the perturbations defined by the profile we put on each input explored without forgetting any value, and we can conclude if it works, what will be the impact on the systems without testing millions of situations. So this case is an industrial and practical applications of formal method to validate neural networks. The limit is that it is a simple systems. It's clearly not an image. We have a tens of physical values, a simple architecture of neural networks, even if they use deep learning. And so the formal methods scales quite well in these situations. For the other, we have to work and push the things more in advance. So I see I am quite at the end of the presentation. Just to complete So there is also activity and good questions regarding the protections of the models themselves against adversarial attacks in particular. And you will find in the slide some reference where we show that using some randomized classifiers can make the system more robust and more robust than some other classifiers that are not randomized. And it's a very important result. And we apply this going from the cat use case or the toy use case from the literatures to a practical use case inside CA for radionuclide identification and concentration estimations. So it's physical signals in spectrometry analysis. They use neural networks to identify which kind of radionuclide is in the air. And they faced to the problem that this kind of environment is very noisy. But they know some profile of the noise. And using the profile of the noise typical of this environment, we were able to reinforce the neural network in order it becomes quite insensible with this kind of noise of its environment. So it's not an attack, but it's behaved like an attack. So another point of robustness, trust, is the reliability, in particular regarding to hardware faults. And some people said, okay, neural networks are natively robust to faults because we have a lot of memory, and if one parameter has some errors, it's not so grave. In fact, some studies have underlined that for a bit or error, we can have a real important degradations of the accuracy for a quite low level of event in the systems. And this level of events of 10⁻⁷ is a concrete situation. It's not an hypothetical that will not happen. It's something that's happened in real. And we have to find some solutions. And some solutions, several work exist, but this one is one option. It's quite easy because it works only at the software levels. The idea is to manage the parity approach and to modify the loss significant byte to create a parity byte. And when we detect some error, to put in zero all the information related to this weight, in order this weight will not influence too much the running of the system. And this shows that we can gain a two-order factor of improvement in the tolerance of bit error on the weight. It's one first step, and probably there will be more other activities on these aspects. What is important is to see, okay, we have also to consider the behavior of the hardware, the impact of the model and the software that implements the neural network, and to reinvent and reconsider the existing solution, in fact, to this context. Just to conclude, the dream would be that we don't have a lot to prove and to develop approach to ensure the trustworthiness of AI and to assess that it will be safe, secure, and so on. And for this, there are some research we are developing to try to introduce a new paradigm called machine discovery, but it's not important. The idea is to say, okay, several years ago we had morphomaths. It works quite well, but not so much well So now deep learning is much more better than morphomats. But we lose something between morphomats and deep learning, is the capability to have a formal specification of what is asked and what's happened. And the idea, in fact, is to say, okay, we will try to reintroduce this concept of formally define, to formally define the task by constructing a first model where we can explain very well all the things, and from this generating other model, but with technique of generation that make the transformation traceable, and checking all the generated model until to find a good model that perform the task as we want and as done by the deep neural network. So to reconsider completely the learning approach. And one way to do this is this of a new internal chair we launched at CEA that try to use the random tensor mathematics used in fundamental physics to develop some learning algorithms having this kind of particularities that are to trace and to be able to explain at each step what has been learned. It will be, it has just been launched. You have 2 publications there that give the main track of the idea on this domain if you are interested. The seminar is in French, and not so easily accessible, but through the publications and the contact of the author, you can have more things. So just to conclude, for developing AI, we have a continuum of challenges from data, algorithms, trust, deployment. I have not talked about this. And architecture, you have a lot of lecture about these subjects. And all of this must be made consistent and ensure a continuum of tools, platforms, and techniques that interoperate. Some reference to other projects. So the first 3 are on tools we are developing at CEA for the development of AI for machine learning. You can find that it's open source, they are open source tools, and just one particular mention is on the deep learning model optimizations and embedded deployment tools, and 2T2. It will be the basis of a very large actions called Deep Green at the national level that will gather more than 30 people at the CEA and about the same from industrial partners to build a national, open, and mature platform for the deployment and optimizations of deep learning models. So if you are interested by this subject, just hear what happens. The official launch should be in September. 3 other projects really focused on trust. Confiance.ai, I have already mentioned it. You have more information on the website. The DEAL project, which is a project developed in Toulouse, also on certifiable AI. You will find a lot of research also on the website. And Taylor, it's important because it's a network of research of excellence center in Europe, focused to the foundations of Trustworthy AI. And it's a quite good signal for me to see that the academic community want to go all together in order to work on this fundamental aspect of trust in AI. And if you want more publications and informations related to safety, in particular for AI, but more largely on trust also, we have launched 3 series of workshops associated with 3 main conferences. One in safety engineering domain, so outside AI to try to put the safety engineering community together with artificial intelligence researchers, and the 2 other with 2 large AI conferences. They exist from more than 3 years, and they run well, and if you go on their site, you will find a lot of very interesting paper. Don't hesitate to go there. Thank you.